Hello guys, today we are going to do the integral of psi x over x squared plus 1 from 0 to infinity. And here, this time I'm going to use the Feynman's technique as well. And I had a video about like 1 year to half years ago, 1.5 years ago, yes, the integral of this cosine x over x squared plus 1, which is equal to pi over 2e. We have a integral like this, pi over 2e. But this time we have an integral like this, but instead of cosine we have sine x. And how can we evaluate this? Yes, we have an integral like this. This time it's just sine x over x squared. And this time I'm going to use the Feynman's technique as well, which is I'm going to let I of a is equal to the integral from 0 to infinity of psi ax over x squared plus 1 dx. And then I differentiate with respect to a, and then we can get 1 over x squared plus 1, which is a constant in our a row. Keep it. And then do the derivative of psi, which is cosine x, and then in our a row, our x is just a constant, so this is just a constant multiple, x times a. So this is just x here. And then here, can we just split it? Try to split it. I'm going to try to use the same method where there's a psi here, because last time we just cosine x, and then we differentiate this, we just get psi. That integral gonna converge, but this time it's not the same. I'm going to show you. I'm going to do pretty much really familiar. I'm going to write this x as our x squared. But here I'm going to put an x here. Prevent, yes, I just need to keep it original. And then here I'm going to do like plus 1 and then minus 1. Then split it, and then I'm going to just cancel the x squared plus 1 and then multiply by cosine x like this. Last time is cosine x, this time is cosine x over x, and then minus the integral of this. And then here, look at this integral. When we put an a here, which is equal to the integral, yes, from 0 to infinity of 1 over x times x squared plus 1. That integral not going to converge. And here, when we put a is equal to 0, which is integral from 1 over x from 0 to infinity, also diverges. This does not converge. This also does not converge. When you have an integral minus each other, which don't converge at all, that's entire integral gonna diverge as well. So I'm not going to do this way. Here, we cannot do this. So what can we do here? This time, I'm going to use a use up. Let u is equal to our, use a smaller pen. Let u is equal to ax, and then du, which is equal to a times dx, and then dx, which is our 1 over a du, and then our u, yes, x in our u row is ax. 唔好講嘢. And then our u in our x row, which is equal to u over a, and then we just get, and then dx, which is 1 over a, and du. So this is 1 over a, put it outside the integral, and then times du, and then x, which is u over a, and then cosine x, which is u over x, which is, I'm going to write this as u squared over a squared, right? And then plus 1, we can just multiply by a squared on the top and the bottom, and then we just get the same denominator, yeah. Plus a squared over a squared, and then a times this a, which is a, and then you just get, flip this a squared to the top, you just cancel out the a squared here. these two, multiply to a squared, and then cancel out with this. So just get the integral of, because u is a dummy variable, we can change it to our x again. And then x times cosine x times over x squared plus a squared dx. And then here, I'm going to do the derivative once again, which is I double prime a, which is equal to, and this time, we are going to do the derivative, x over x times cosine x is a constant in our a row, and then we are going to do a derivative of this 1 over that. How can I do a derivative? First step, I'm going to just square this thing, 1 over the square of this, and then and then put a negative sign in front. This is the root of the derivative of 1 over f of x. And then negative, and then x cosine x is a constant, put it outside. Yes, not outside integral, put it here. And then times our, use our chain rule, multiply by, yes, 2a. Derivative of this thing is 2a in our a row. And then here, we can put a constant negative 2a outside the integral. So this is just equal to negative 2a times the integral from 0 to infinity of x times cosine x over x squared plus a squared dx. And then here we can use our partial fraction, not partial fraction. This is integration by part, so we are going to use the DI method. I'm going to differentiate cosine x and then integrate x over x squared plus a squared squared. Differentiate cosine x is easy, which is negative sine x. And then how can we differentiate this function? Consider we have a function like this, 1 over x squared plus a squared. When we take the derivative, dx in our x row here, because we are doing the integration by part in our x row. So we have to use the variable x, which is pretty much the same. Square this, and then use the chain rule, multiply by the derivative of this, which is in front you have a negative, and then do the derivative of this thing, which is our 2x. Because the derivative of this is equal to this, so when we multiply by negative 1 over 2 on both sides, you just get the integral of x over x squared plus a squared squared, which is equal to negative 1/2 times 1 over x squared plus a squared. So we are going to distribute this times this, which is equal to, first step, negative 1 over 2 times negative 2a, which is positive a, and then times cosine x over x squared plus a squared, and then you evaluate from 0 to infinity, and then you have 4 negative sign here, 1, 2, 3, 4. So we are going to get positive, and then 2 and 2 cancel, so this is just positive a here. Time the integral from 0 to infinity of sine x over x squared plus a squared dx. And then here, to the limit of this, limit cosine, when you take a infinity here, this is just really big, which is much bigger than cosine x, which is the numbers always gonna, the domain is from -1. Yes, not domain. The result always gonna be between -1 to 1. So this thing is way bigger than that. So that limit is gonna be 0. And then we are going to minus, put a 0 into it. Cosine 0, which is 1. And then 0 squared, which is 0. And then over a squared. So you can get this. And then this thing, I'm going to use the substitution, but this time is in terms of x. So this, I'm going to let x is equal to 80, which dx will give you d a dt, so we can get a times a, which is a squared. And what is t in our x row? So this t, which is equal to x over a, and then put infinity and 0 still the same, upper limit and lower limit. And then x, which is sine 80 over, take a square of this because x squared, so this a squared t squared. I'm going to factorize the a squared, So we can get 1 t² plus 1 here. And then a² and a² get cancelled. And then therefore we can get a times -1/a², which is -1/a. And then plus, and then this just a dummy variable, the t, we can change it back to our x, which we can get this. And this is just our original. We just repeat the original I of a, sin ax over x² plus 1. So this is just equal to our I of a. We do it the second derivative. The second derivative of I of a, which is equal to -1/a, and then plus 1 I of a. We can move the I of a to left hand side. We can get the differential equation I double prime a minus I of a, which is equal to -1/a. And this is just a differential equation, second order differential equation with with undetermined coefficients. You can get this is not equal to 0. So this is first we are going to find the homogeneous solutions to this. First, we are going to look at this. This is the second power, so this is going to be m, and this is just the first power. 0 power, because there's 0 derivative. So this is just -1, which is equal to 0. Move a 1 to one side and take a square root. You can get 2 solutions, which is m is equal to plus or -1. So we are going to get our homogeneous solution to this. We are going to use our I here, I think. I of a with our h homogeneous solution to this. But this solutions has two roots. We can get c1 times e to the power of this thing, which is e to the power of this thing times a. This is our a. 1 times a, which is a, and then plus c2 times e to the power of -1 times a, which is -a. This is our non-homogeneous part. To find the p part, variation of parameter, we are going to use that method. We can use the Whiskaton, I don't know how to pronounce that method, which is w. Use our determinant, which is we are going to replace the c1. Yes, c1. We are going to put e to the a and e to the power of -a here. And then differentiate this e to the a, which is e to the a again, and differentiate e to the power of -a, which is -e to the power of -a. And then do the determinant this time, this e to the power of a times -e to the power of -a, which is -1. And then minus e to the a times e to the -a, which is 1. So we can get w, which is equal to -2. And then we are going to find w1, which is, we repeat this thing on the right hand side, then we place the left column with our 0, and then this thing -1/a here, and then do it 0 times that, and then minus being positive, so there's e to the power of -a/a. Now w2, which is equal to, and then we place this with 0 and -1/a, and then e to the a left hand side. This time that we can get -e to the a/a. Therefore, we can get our p part, parameter part, which is equal to c1. We can get our u1 here. Our u1, which is equal to, first step, we are going to find the u1 first. u1, what is u1? Our formula, which is u1, which is equal to the integral of w1 over w. w1 over w, which is e to the power of -a/a over -2, which is just -1/2 in front, times e to the power of -a/a dA. And at this thing, we can use our substitution, which is we can use our k, which is equal to -a, and then dk, which is equal to -dA, and the dA, which is equal to, we can just replace this negative side, which is equal to negative dA, which is dk. So we can just get dk here. And then e to the power of k. And then our a in our k row, which is negative k. Put the negative sign in front and then integrate e to the power of k over k, which is our exponential function. So this ei of k, and now k, which is our negative a. And then don't need a plus c here. And then u2, which is u2, w2 over w, which is negative e to the a over negative 2, which is put a 1/2 in front, times e to the power of a over a. This is really easy, just ei, exponential integral, ei of a. Therefore, we can get our homogeneous part, yes, variation parameter part, which is first c1 times that, c1 times this negative 1 over ei of a, which is negative 1 over 2 e to the a times ei of negative a. And then e to the power of negative a times this, which is positive 1/2 plus 1/2 times e to the power of negative a times ei of a. Therefore, our solution to this, which is c1 times e to the a plus c2 times e to the a minus 1/2. I'm going to write the positive plus 1/2 e to the power of negative a first. And then minus 1/2 e to the a ei of negative a. And then c1 and c2, I'm going to make a video soon. And these two constant are just equal to 0. Therefore, we just get this thing. We can just erase in front. We can just get e to the a, I of a, which is just equal to this thing. Then we move the positive side. We can get this is equal to this beautiful thing. I'm going to use this thing. We can get these beautiful solutions. And then original integral is equal to psi of ax over x squared plus 1. Therefore, I'm going to write it down. Psi x over x squared plus 1, which is just put I is equal to 1 here, which is 1/2 e to the power of negative 1, bring it to the denominator, which is 1 over 2e times ei of 1 minus, and then e over 2 times ei of negative 1. And this is our result, and thanks for watching. Really cool, huh? And bye, this is our result, and stay tuned for more quality videos. And yes, good evening. Is 12:37 a.m. here, and goodbye. Really cool result. 1 over 2e and then e to the e over 2.